Okay, this video we're going to cover solving some trig equations in getting general solutions and also getting solutions over a given interval. And we'll do a couple with radians, a couple with degrees, a couple nice number ones, and a couple kind of not nice number ones where you're going to really rely on a calculator. So anyways, let's take a look. I'm not going to do all of these, but we'll kind of jump through. I'll do some of the more challenging ones or whatever to get the idea. So starting with number 71, we need general solutions. And the idea with general solutions is you're going to need to list um, all the solutions. Okay, because again, these have an infinite number of solutions due to the how the trig functions always repeat themselves and go over and over. So if it says the word general, you're going to have to throw like a plus 2 pi k on or a plus 360k or something like that. So let's look at part B. Part B, 4 cosine squared minus 3. So you always want to start out by just doing some algebra and get the trig function by itself. So let's add the 3 to both sides. And then we will divide by the 4. Pick it up over here. So cosine squared x is going to equal 3 over 4. And then again, just think algebra. This is something squared, so we need to take a square root here. And we will just take the plus or minus square root over here. And we'll be left with just cosine of x. I'm going to write the square root. Really what we have is the square root of 3 over the square root of 4. If you're taking the square root of a fraction like that, you can split it up into 2 square roots. And of course the square root of 4 is really just 2. So this is really plus or minus the square root of 3 over 2. And now it's just a matter of knowing what angle, okay, it's saying like the cosine of something equals root 3 over 2 and negative root 3 over 2. Okay, so you got to know your unit circle. If it's a root 3 over 2 or a root 2 over 2 or 1/2 or one of those unit circle values, we want to be exact here. Now they didn't specify radians or degrees, so let's just stick with degrees because that's usually a little easier. So one way, again, once you get to this step, if you're still kind of unsure, you can always go in your calculators and do an inverse function. To check your mode, again, I'm going to stick with degrees because this one didn't specify. And our equation was basically what I want to solve is we were down to cosine of x equals root 3 over 2. And I'll worry about the negatives separately. Okay, solving this basically by doing an inverse cosine on both sides. And I'm just doing the positive root 3 over 2 because I just want to get the reference angle. Okay, and the thing that happens is the cosine inverse actually cancels the cosine, and we will be able to solve for x just by doing that part in our calculator. So I'm just going to calculate second cosine. There's the inverse cosine. Now just be careful. It's a square root of 3, and then scroll over, get out of the square root, or sometimes there's a parenthesis you need to close there. But make sure this divided by 2 is not under the square root. Okay, and this is going to give me an answer of 30 degrees, which again, some of you probably knew that just from the unit circle, because 30 degrees has a cosine of root 3 over 2. But I was just showing a way to, kind of verify it if you can't remember. So 30 is the reference angle. All right, and we got to think about now, since we have this plus, let's jot this down. The reference angle is 30 degrees. And now here's the thing, we have this plus or minus here, so I really could have the cosine being positive root 3 over 2 or negative root 3 over 2. And if you think about all 4 quadrants here, the solution, if we're in quadrant 1 and that's 30 degrees, then the actual angle is 30 degrees. So that's one solution. Okay, that's a positive, that has a positive square root 3 over 2. The other place where it's positive is in quadrant 4, okay, because again, cosine is an x value, and in quadrant 4, the x values are positive. So if that angle was 30 degrees, the reference angle there, the question is how big is this entire angle? So the rule for fourth quadrant is always 360 minus 30. Okay, so 330 degrees is another answer. And now what about where is the cosine going to be negative? Root 3 over 2. So x is negative in quadrant 2 and quadrant 3. So if we put our 30 degree reference angle in those quadrants and ask yourself how big is it from there to there, okay, it looks like we are just 30 degrees short of 180. Right? Quadrant 2 is always 180 minus the reference. So that would be a 150. And then finally in quadrant 3, if the reference angle is a 30 right there, that angle is going to be, quadrant 3 is always 180 plus the reference angle, so 210 degrees. Okay, so those are the four solutions. Now to make them general, we would need to throw on a plus so for each of these, it's going to have a plus 360K. And what that does is it says you can add 360 to it, because think about if you add 360, you're going to end up in the exact same spot. And then the K is just saying you could add any number of 360s, any multiple of 360s, because you can go around the circle 100 times if you want. So K is basically just like any integer multiple. It could be a negative number. Right? You could be adding or subtracting 360 basically is what it boils down to in that case. Okay, so that's that should be your final solution for number 4. Or I'm sorry, number part B. Okay, 72. They were kind of asking why is 2k pi part of the solution? So if we would have done this in radians, instead of adding 360k, we would have added 2 pi k, 2k pi. And the reason again is the same thing, because it's a general solution and it's going to keep repeating for every revolution of the circle. Okay, let's do part A for number 73. That one looks a little bit more difficult. So if we start by adding the 1, cosecant squared x, I'm going to add 1 to both sides, so that 3 is going to become a 4. Okay, now we're going to go ahead and take a square root again. So when I take the square root of both sides, I'm going to get cosecant of x. The square root of 4 is 2. Okay, so let's split this up. Cosecant of x could be 2, or cosecant of x could be negative 2. Right, the plus or minus means we got to check both. Now, I don't really deal with cosecants, any of the reciprocal ones that often, so let's just kind of change this into reciprocal. And remember, cosecant goes with sine, it's its reciprocal, right? So if I take the reciprocal of cosecant, it's going to become sine. And if I take the reciprocal of 2, remember that's 2 over 1, so its reciprocal would be 1/2. Same thought over here, except it's going to be negative 1/2. Okay, so now we need to figure out what is the angle. Here's where again you need to know your unit circle, or you can use your calculator for the inverse function. But we need to watch out. This time they're specifying over an interval of 0 to 2 pi, so we need to leave this in radians. Okay, so I'm thinking to myself, what angle has a sine of 1/2? And again, think on your unit circle, since 1/2 is a nice unit circle value. 1/2 is the one that has the lowest y value. It's not the high one up here. That one has a sine of root 3 over 2. So it's the little angle, it's the 30-degree angle, which is actually pi over 6. Okay, so that's going to be our reference angle, and that will actually be one of the solutions to this when it's positive 1/2. Okay, where else is sine positive 1/2? In quadrant 2. Okay, y values are positive in quadrant 2. If that's pi over 6, I think we are actually pi over 6 short of a full pi. Right? Think of this 180 right here is actually 6 pi over 6. And if we're pi over 6 short, we are left with 5 pi over 6. Okay, so those are the two solutions for the positive portion. Okay, for the negative portion, there's quadrant 3 and quadrant 4. If we put our pi over 6 right there, notice we're now that much farther than full pi. We've gone the 180 or pi plus another pi over 6. So that's 6 pi over 6 plus pi over 6. So 7 pi over 6. And in the fourth quadrant, it's also negative there. And we're not quite 2 full pi. We're stopping short of 2 full pi. We are a pi over 6 short. So you got to think about 2 pi is really 12 pi over 6, right? I want to divide it into sixths because that's what my reference angle is, was pi over 6. So I'm 1 pi over 6 short of that. So 12 minus 1 will give me 11 pi over 6. And I don't need to do the plus 2 pi k or anything, because this is talking about just on one revolution around the circle. Okay, let's look at a couple more here. We'll do one of these for number 74. It looks like, let's do part B. That one looks a little messier. Plus, we haven't done a tangent one yet. Just notice this one wants us to be in degrees, and we want to be within 1 revolution, so anything between 0 and 360. Okay, so part B, Let's get everything on the same side of the equation and try and do some factoring. This is one that definitely has some algebra going on. So if I were to add the root 3 tan squared theta to the left side, okay, I'm basically just adding this whole term over there, getting it equal to 0. Okay, then we can do some factoring. Okay, now what I notice is both terms share at least a tangent of theta, right? This one has, the first one's tangent cubed, the second one has a tangent squared in there, so I can bring a common factor out. I can actually bring out tangent squared theta. That's the GCF there. They both have at least a tangent squared theta. Okay, and what would be left would be, to get tangent cubed back, I would need to multiply by another tangent. And then to get the second term back, I would need to multiply by root 3. So let's make sure we're clear on the factoring. It's probably been a little while. But notice this times this would get me that, right? And then tangent squared times root 3 would get me root 3 times tangent squared, right? So we're just, it's some old algebra, factoring. Still equals 0 here, so let's finish this out. So now it's factored. I can set each factor equal to 0. Okay, so I'm gonna give myself some space here. I'm gonna set the tangent squared theta equal to 0. Solve that, and then let's give myself some room over here. Tangent, the other factor is tangent cubed plus root 3 equals 0. Okay, so with the tangent squared equals 0, if I just take the square root of both sides, the square root of 0 is still 0. So now the question is, where is tangent 0? Okay, in a couple ways again, you can go in your calculator and do an inverse if you want, or you can kind of think about tangents y over x, right? So wherever y is 0, which is going to be at, this one wants degree mode, is that right? Let's make sure, yep. So 0 degrees, and actually at 180 also, right? Those are where the y coordinate 0, so tangent is 0. So those are the two solutions to that one. And again, you always have you can always do an inverse tangent. Thing is, the inverse tangent is probably going to just give you the 0 answer. You need to know about the 180 also. Okay, so you gotta, I'd really rely on the unit circle. Solving the other piece, subtract the root 3. And now where is tangent negative root 3? Again, I know this is a 60-degree reference angle. If we just want to see it on the calculator again, remember to find the reference angle, you actually ignore this negative sign for the time being. Okay, so I'm going to go in and do an inverse tangent of root 3. Okay, and I'll show you why. If we would have done it without ignoring the negative, let's say we would have done an inverse tangent of the opposite of root 3. Okay, so this is going to give you a negative 60 answer. Okay, and the reason I don't want to use negative 60 is the following. It's kind of a little detail, but it's to get it totally correct. You don't want to do that. The interval they want our answers in are from 0 to 360. Okay, so a negative 60 degrees is not in that interval, right? It's negative 60 is not between 0 and 360. So what we actually do is just think about the reference angle is actually 60 degrees, and we're just going to place it in the correct quadrants. Okay, so wherever tangent is negative, which is actually quadrant 2 and 4. Okay, if I had a reference angle of 60 degrees in quadrant 2, how big would the actual angle be? 180 minus 60, right? So 120 degrees is an answer. If I go down in quadrant 4 and have a reference of 60, how big is the actual angle? 360 minus 60, so 300. Okay, so this thing has all 4 of those answers. There's the 2 from the second piece, there's the 2 from the first piece. Okay. All right, and let's do one of the ones from the second part of the section. Why don't we do number 76? So let's do a little algebra on that. Let's subtract the 11. 4 cosecant of x equals negative 11. Divide by the 4. Okay, so always do algebra first. Now again, oops, I missed a C in there. Cosecant x. I don't really like dealing with cosecants. I know the reciprocal of cosecant is sine x. So if I take the reciprocal of that side, I can just take the reciprocal of this side. Okay, now here's one where that's not a nice unit circle value, right? The 4 over 11 or 4 over negative 11, it's not a root 3 over 2 or a root 2 over 2 or anything like that. So what we're going to do is actually we have to use a calculator. And this one, they want our answers to the nearest tenth of a radian. So we're in radian mode in between 0 and 2 pi. The only way I'm going to get the reference angle is by doing an inverse sine on both sides. Okay, so that's going to undo sine. So we're going to end up having x is, from our calculators, the inverse sine. Now again, we don't do it as a negative like we talked about before. You get the reference angle by doing it as positive. Okay, so let's do that on a calculator. Radian mode, inverse sine of 4/11. Okay, so I think I need to switch modes. So always, be careful going back and forth on modes here. Inverse sine. Again, I'm doing it as a positive 4/11 because I don't really want to get a negative answer. I'm going to place it in the correct quadrants. But here's our value. It's 0.372. And remember, that's radians. Okay, so that's radians. So it's not 0.37 degrees. It's not that small of an angle. Because if you think about, your unit circle in radians, if that's 0, this is pi, which is really 3.14 radians. So the 90 degrees is half of that. Let me just get a number here just so we can get a visual. Oops, let me put that marker down. Just so we can see where this angle is actually going to be. Pi, that would not answer. Pi over 2, just to get a ballpark figure, is actually 1.57. So a 90 degree angle is like 1.57 radians. We need to be 0.37. So we're, somewhere, what's half, 0.8. So we're probably somewhere around here with our 0.37 radians. Okay, so that's just to visualize it. So 0.372 is our number though. That's our reference angle. And now if we just place this in the correct quadrants, we should be good to go here. So our original equation was going back to where cosecant is negative, or where sine is actually a negative number, right? So that's going to tell us which quadrants we need to be in. So sine is negative in quadrants 3 and 4, right? It's all about y values. So down here, if this reference angle is 0.372, the question is, how big is it in standard position? Okay, quadrant 3. So in quadrant 3, again, this is pi radians, so we went a little bit past pi. One of our solutions is going to be pi plus 0.372. So whatever that number equals, we'll do that in a second. And also in quadrant 4, the sign is negative. So if the reference angle is 0.372 radians there, how big is this entire angle? Standard position, it's actually 2 pi minus the 0.372. Okay, so let's do that real quick. Get our numbers here. So pi plus 3.372. And remember, pi is the regular pi, the 3.14. It's not 180. We're not doing anything with degrees in this problem. So let's clear some of this off here. Pi plus the 0.372. Okay, so that should be one of your answers. Second answer was 2 pi minus 0.372. And we could round these to the nearest tenth like it wanted us to do. So I would go 3.5 and 5.6. And again, that's all in radians. So it seems weird to have radians that don't have an actual number pi in them, like a pi over 5 or pi over 6 or whatever the numbers are. But radians can be thought of as decimals. Okay, so just like the real value of pi. Okay, and hopefully that helps. That should get you through the majority of these problems. Yeah, so the only difference in the second half of the problems was that your answers were not on the unit circle. So you had to use a calculator to finish these. Once you get to this step, like there's no way to know what the angle is without really using a calculator. You could have done the same process on the first ones. Just make sure you leave your answers exact though. All right.